Hey guys, so you should have two different note sheets to use, so go ahead and get out the notes for 7.1 first, and we'll take a look at zero property and negative exponents. So the rule for the zero as an exponent is that for every non-zero number, a, which is your base number, if it's raised to the power of 0, the answer would always be 1. So we've got a couple examples on your note sheet, just practicing with this rule. It is really easy, do not overthink it. So a to the 0 power is obviously 1. Negative 3, because both the negative and 3 are in parentheses, to the 0 power 1. And I know there's all this stuff going on in parentheses, but because the whole group of parentheses is to the 0 power, the answer is still just 1. So that should be easy. So one of the laws of exponents is about negative exponent property, and this property states that for any non-zero number a and any integer n, when you have something raised to a negative power, like a to the negative n, then you technically are taking the reciprocal of that number and rewriting it as something like 1 over a to the n. So basically what it means is when you see that negative power, the negative, all it means is move it to the opposite side of the fraction bar. And you might be thinking, well, what fraction bar? But if you had a to the negative n, you could technically make that a fraction by putting it over 1. And then if you're going to move it to the other side, you're going to just flip that and do the reciprocal or move that a to the n to the bottom. Once you move it, the negative drops. So we've got a few examples. First example is 7 to the power of negative 3. So if we're going to go ahead and rewrite that, the negative again just means move it to the bottom. So we would need a fraction bar, and we're going to go ahead and move 7 to the third to the bottom. Since there's nothing that was already a fraction, we're just going to make this reciprocal, so 1 over 7 cubed. And then because this is an actual number, you can cube 7. So we can actually simplify this and call this 1 over 343. Second example, we have negative 3x to the power of negative 2, and it's important to realize there is parentheses around the negative 3x, so that whole thing has to move to the bottom, and since there's parentheses around it, you should keep the parentheses around negative 3x. The negative just means we're going to move it to the bottom, and then we're still going to have a squared from that. We can't really simplify this one yet, so we can just stop there. Final answer would be 1 over negative 3x squared. And then your third example, we've got three different terms. You have 4, and then x to the negative 2, and y to the 5th. So the rule states that only things that have a negative exponent would move. So in this case, the only thing I see here that has that negative exponent is our x to the negative 2. So that's the only thing that's going to move to the bottom. And then what stays up at the top is the numbers that did not have negative exponents, so that's 4 and then y to the 5th. So in this case, your final answer at that point is 4y to the 5th over x squared. So for a shortcut, what you can think about what we did here is that when you see a negative exponent, you're going to take that term that it's touching and its power and move it to the opposite side of the fraction bar and then get rid of your negative exponent. So negative exponent just tells you opposite side or opposite part of the fraction. So having a negative on top will end up moving that term to the bottom, and having a negative on the bottom, if you ever had a problem like that, then you're actually going to move that term up to the top and then make it positive. So you have 4 practice problems. We're just going to take a look at how these would work just to get a little bit more practice with this, since I know it is something kind of completely new. So problem 1, 2x cubed y to the negative 5th. If we're to simplify that, we need to get rid of the negative exponent in order to simplify. So I like to always start by drawing a fraction bar. Anything that doesn't have a negative exponent is going to stay as part of the numerator, so that's the 2x cubed. And then the y to the negative 5th has that negative, so it has to move to the opposite side. So that's going to move to your denominator and become a positive y to the 5th. Second example, 21x to the 0 and z to the negative 6. So again, I like to draw my fraction bar. What's going to stay is my 21 and technically my x to the 0. And then what's going to move is my z to the negative 6, but it becomes a positive when I move it. And then according to that first property we looked at, that anything to a 0 power, like this x to the 0 power, really is just 1. And because this is being, this x is touching 21, it means times. So that's just like saying 21 times 1, which is really just 21 over z to the 6th. Just be careful that you don't add that and try to make it a 22. It's being multiplied, so 21 times 1 doesn't change. Number 3, So we've got 2x to the negative 2 and then 5y to the negative 4. So again, keep in mind that only what the negative is touching has to go. So if I look at the numerator, that negative exponent's only attached to the x, not to the 2. So the 2 is going to stay on the top, but that x to the negative 2 will move to the bottom. On the bottom right now you had a 5, there's no exponent with 5, so that stays, but that y to the negative 4, because of the negative, is going to move, and this is where if you have a negative on the bottom, it's going to move to the top. This just becomes 2y to the 4th over 5x squared. And then number 4, write your fraction bar. The entire numerator, 4x, is in parentheses, and so both of those technically have that negative exponent, so both of those should move to the bottom and stay in parentheses, but then get rid of your negative exponent. And then on the bottom you have y to the 0. Again, y to the 0 is really just 1, so it could stay on the bottom as 1, but because we've moved 4x cubed down to the bottom, we have to make this a reciprocal, so we're going to have to put a 1 on top anyway. And that's it for the notes on 7.1. Don't worry about the back. We'll do that in class next time. So we're going to jump straight into looking at your 7.3 notes when you're multiplying powers with the same base. So go ahead and get out that note sheet. All right, so let's take a look at when you multiply powers when you have the same base. So we're going to be using a lot of different words when we talk about our laws of exponents. So it's important to know whenever I say base, that's going to be the number that's the big number. In this case, it would be the a, and then n would be the power or the exponent. So just keep that in mind as you hear base and power and exponent, you know which one we're talking about. All right, so your rule for the product of powers property is that when you have something like a to the n times a to the m, then you really are going to do a to the n plus m. If that's confusing, don't overthink it. It's really just saying you're going to add your exponents when you have the same base. So the rule really says multiplying powers with the same base, you keep the base, which was the a, and then you add the exponents, which was your n and your m. So rule, same bases, and you're multiplying them together, you're really just going to add those two exponent numbers. So it should be pretty easy, and there's actually a common reason why you would do that, and we'll kind of expand it so you can see, but the rule is definitely quicker instead of expanding each problem. So let's take a look at your examples. 4 cubed, realistically, and I'll show this one expanded, means 4 times 4 times 4. And then if we're going to multiply that by 4 squared, which is 4 times 4, what we really have here is 1, 2, 3, 4, 5, 4. So we can technically rewrite that as 4 to the 5th power. And the way we could have got that without expanding all of this is by saying, hey, I have these same bases of 4, and I have these two different exponents, 3 and 2. Well, the rule here says if I multiply the same bases, all I do is add those exponents, and 3 plus 2 is where my 5 comes from. So that is the general shortcut rule. Again, just because this one's a number base and we know we can actually figure out what 4 times 4 times 4 times 4 times 4 is, you can actually do the math for these. When it's variables, you can't. So we're going to go ahead and do the math, and you end up with 1,024 for that. Second example, so you have the same base in each of these. You have x squared times x to the 4th times x. Again, if you were to expand it, that would be 2 x's in the first one, 4 in the next, and then a 1x in the third one. So you could expand it to see and then count how many x's you have to simplify, or the rule is really just to add your exponents. So this is just saying add 2 plus 4, and then be careful with this last one, that's still a 1. So final answer here should be that you end up with x to the 7th when you simplify and add your exponents here. And then the third one, a little bit different because we have different kinds of bases going on. So you've got these numerical bases where you have 3, and this means 3y cubed times 2y to the 5th times negative 1y to the 8th. Since the 3, 2, and 1 are not all the same base, they're not like 3, 3, and 3, then you just treat this as regular multiplication. So the rules of exponents only apply when you have the same bases, and these are all different numbers, but it's still multiplication. So when you're simplifying this, just do 3 times 2, which is 6, times negative 1 is negative 6, and then you treat your y's, because you have those same bases, using this rule where you're going to add. So we had 3 y's. We're going to combine that with these 5, so that's going to be 8 y's plus 8 more y's, so then we end up with y to the 16th. So the rule only applies when you have common bases where you add the exponents. If not, you're just plain old multiplying. Okay, so we'll take a look at some more examples. We're just practicing with multiplying and adding exponents. 1, 3a to the 6th times a to the 8th. 3 is just 3. It's multiplied by, if I wanted to use identity property and put a 1 there, times 1. So that's going to be 3. And then if you had 6 a's and you multiplied it by 8 more a's, you're really going to add those to get 14 a's. Second example, you're going to go ahead and multiply your numbers. So 8 times negative 3 times that would be a 1 would be negative 24. And then we have two different variable bases. We have x's and y's, so we have to do them separately. This is where people that like to highlight, I always tell them this is a good time to use your highlighters, and you can actually just highlight the different bases that you have. So I've got x squared and x here, and then I've got my y squared, y to the fourth, y to the third. So I can only put them together if they're like bases. So we'll do alphabetical order. That would just be your standard form. So I have x to the second times x to the first. That would be adding the exponents to get x to the third. And then your y's, you've got 3, 2, and 4. So when we add those, it's going to end up being y to the ninth. So final answer, negative 24, x to the third, y to the ninth. Example 3, we've got first 2 times 3, which is going to give you 6. Looking at your x bases, you've got x squared times x to the 5th, so we're going to add those to get x to the 7th. And then we have y to the negative 4, and then y to the 8th. So we're still adding, it's just using integer rules. If you add negative 4 plus 8, you're going to end up getting positive 4. And from there, we are done. Okay, example 4, again, multiplying 3 times negative 2 gives me negative 6. C, I have c to the first and then c to the second. So if I multiply, I'm really going to add to get c to the third. And then d to the negative 4 and d to the 8th, you're going to really add, and that should end up being negative 4 plus 8, which is another 4. So final answer done. And then example 5, numbers, you would technically have a 1 in front of the p, times negative 7 times 2 would end up being negative 14. With our bases, we've got p to the negative 3 and p to the positive 2. So we would say negative 3 plus 2 is negative 1. We're going to keep it like that for now. And then our s base, we've got s to the 1 and s to the 4, which makes s to the 5. Now, at this point, you're technically not done simplifying because you have that negative exponent. And whenever something says simplify, that means you do not ever want to have something with a negative exponent. So we're going to go back to what the first section was on, which is rewriting this and getting rid of the negative. So the things that don't have negatives are going to stay on top of my fraction bar, which is the negative 14 and s to the 5th. And then that negative exponent needs to move the p to the first down to the bottom. So your final answer here should be negative 14 s to the 5th over p to the first with no negative exponents. Okay, this is on your notes, and I actually gave you multiple choice here, so you can try this one and then pick an answer out of these 4 and see what you get, and then press play when you're ready to check. And final answer for this one should have been option 3, 20r to the first, s to the 5th. And again, you're just multiplying and then adding your exponents for your like bases. And your last practice one, number 7, a little bit more going on, so just be careful. Go ahead and try this one on your own. Just take it one step at a time. Multiply your numbers first, then look at your A's, then your B's, then your C's, and see what answer you come up with here, and then press play when you're ready to check that. So final answer for this one actually should be option 4. So when you multiply first, you end up with negative 6a to the 4th, b to the 2nd, and c to the negative 5th. But again, we have that issue with that negative 5 where you don't want to keep that as a simplified answer. So you would move that to the bottom or the denominator, which matches up with option 4 here. So the back of this paper, again, you don't have to do. We're going to do that in class as practice. So at this point, you're officially done with notes. Just make sure you have both of these with you so that you can do the practice in class next time I see you guys. And have a good day.